So welcome. This is Make the Backend Team Jealous, Elm in Production. So my name is Richard Feldman. I work at a company called No Red Ink. And we make grammar and writing software for English teachers. And our stack since day one has been Ruby on Rails. So there are two parts to that. You got the Ruby part and you got the Rails part. Let's talk about Ruby. So Ruby is a language that's known for having a good user experience to use it. It's a nice language. It's designed to be a nice language. It's pleasant to use. You get a lot of stuff done in it. I'm really big on user experiences. I love creating user experiences. I love building user experiences. I love watching people be delighted by the stuff that I build. And I also care about the tools that I use. I like being delighted by my tools. Because I care about user experiences and because I build for the web, which I personally believe is the best app delivery platform the world's ever seen, I spend a lot of time with a different language. This language, JavaScript. JavaScript has some things in common with Ruby, but there are some things that are not as nice. There are some sharp edges, shall we say. And I've spent a lot of time thinking, why can't JavaScript be more like Ruby? I'm jealous of the back end. Like, why do they get all the nice tools? And of course, there's a good reason for this, which is that on the back end, you're writing for the server. On the server, you can run machine code. You can run whatever language you like. On the browser, you've got JavaScript, and you can write whatever language you like as long as it's JavaScript or compiles to JavaScript. So on the server, any language. In the browser, any JavaScript you like. So since I'm a UI guy, I spend a lot of time dealing with this question. So JavaScript's getting better. This ES6 is fewer sharp edges than ES5, kind of, sort of. We've seen CoffeeScript get a lot of adoption, sort of taking JavaScript in a more Ruby-ish direction, making things a little bit nicer, polishing off some of the bad parts and just removing them. And then, of course, now we're seeing languages that have very different semantics from JavaScript compiling to JavaScript, such as Elm. We'll come back to that in a second. First, I want to get to the other part of that. So Rails. Rails is not a language. Rails is more of an idea. It's sort of an architecture for the way you can build web applications. So we've got another big architecture that we use at No Red Ink, which is React and Flux. I remember when these came out, Facebook open sourced them, and we adopted them pretty much right away. They've been fantastic. They've really made it easy to organize things that used to be problematic, especially as code scales. So whereas before we used to have this potentially large tangle of things where this updates this, and then this updates this, which updates that, which maybe updates the first two things, and you get kind of these cascading updates and things get difficult to manage. React and Flux organize things much better. So we have a lot of wires going on here. There's a lot of stuff happening, but you can very cleanly see the organization of it. You can see, okay, all of the orange wires are grouped together. They follow a certain pattern. The yellow wires, the blue wires, the green wires. They all kind of come together in a coherent system. And so despite the fact that there's a lot going on, it's organized. It's easier to deal with. So I want to show you quickly one of the interfaces that we build using this stack. So this is Ruby on Rails, CoffeeScript, React, and Flux. So essentially, this is for teaching kids how to do active voice and passive voice. Raise your hand if you feel totally comfortable with active voice and passive voice. All right, cool. Pop quiz. Halle Berry's new movie was watched by me at the IMAX theater. What's the active voice version of that? Nice. All right. Yeah, so it's I watched Halle Berry's new movie at the IMAX theater. So because we care about pedagogy, we care about efficacy, we care about teaching kids how to do this stuff, one of the goals of our tool is to get kids not just to get the right answer, but to actually understand why they got the right answer. And to make the mechanical motions that they're making in the course of answering the question line up with what they should be thinking about when they're going from passive voice to active voice. So this is the interface we ended up with. So there are a couple of different things you can do here. You can drag around any of these sections. You can click to cycle through the ones with dots under them. So we can do this, basically rearrange this sentence to be what everyone shouted out. So we'll say, okay, I want to say I watched. So I'm going to drag those, and then I'm going to click to change I watched Halle Berry's new movie. We have this extraneous by, so we can drag that out of the sentence. And there we go. I watched Halle Berry's new movie at the IMAX theater. So in the course of doing that, I was physically rearranging the sentence in the way that the student's mind would be working when they're thinking about the transformations to make. If we just had a big text box, yeah, they would have more options, they would have more flexibility, but they wouldn't be focusing on the right things for this type of question. So there are a couple of things to note about this interface. There's actually kind of a lot going on, even though it's pretty simple, just drag and click. For example, we have this grouping of sections, which works great when you have sections that are small like this, but when you have longer ones, they either need to wrap, or you end up with, when you have several long sections, this big stacking thing that no longer looks like a sentence. So we had to do this ourselves. This is wrapping. There's no CSS for display-jagged-edges-wrap. We had to come up with this ourselves and do the wrapping ourselves and still make it feel to the kid as though it's just one section. And of course, when you pick this up, it stops doing that. Another thing to notice, since I've picked this up, at is lowercase. But if I drag it to the beginning of the sentence and drop it, it capitalizes it for me. I also can't drag it past the period. The period's always got to be at the end of the sentence. So again, we're trying to focus on the things that matter in this sentence and leave the kid not worrying about capitalization, punctuation, stuff like that, just active and passive voice. And this has been really effective. I've seen Jossie, our curriculum lead, we do these classroom observations where we'll go and show a new interface that we're working on to kids and just make sure that it's actually doing the job that we want it to do. So I saw her give, this was middle schoolers, we're not even supposed to have learned this yet, about a 30-second primer on active voice and passive voice and just set them loose answering these questions. And at first they were getting them wrong, they were struggling with it, but as they started to learn the motions and get the feedback from the system, by the end of it, after about 15 minutes, they were all doing it. They got it, it worked. And that's something we really care about. But that was not the first version of this interface. The first version of this interface, I'm going to say it seemed like a good idea at the time. Kind of like solve the problem in sort of a, direct way. It was a lot simpler than that. We didn't jump right to implementing our own CSS wrapping by hand. We said, OK, we think this is going to be effective. And then we took it out and we showed it to kids. And it was totally not effective. They were just totally lost. Like, it was a bad scene. We said, OK. We care about user experience. We care about efficacy. We're going to go back to the drawing board. We're going to come up with a new design. So we did. We iterated. We said, great. OK, we're going to iterate on this. We're going to find a new design that we think will be more effective. Cool. Built it. Took a while to build. Great. Took it out to the kids. And boom, nothing. Still not good. So we had to iterate again. And so eventually we got to that design. It was effective. Everybody wins. The trouble was, in the course of doing that, we had to rearrange all of this. So we had this very neat organization, thanks to React and Flux. But now we said, OK, we've got this current design. It's not effective. We need to get to this new design. And the English description of how you would get to that new design is something around the order of, OK, I need to take every third orange wire and swap it with every other blue wire. Now, I didn't just say very many words. But if you're thinking about that, ooh, that's not going to go. OK, there's going to be a lot of unplugging and plugging back in. It's going to be very error prone, right? And if you're working with this stack, CoffeeScript, React, Flux, when you have something of this form that is conceptually easy, I can describe it in fairly few words, or a whiteboard diagram of the design that is mechanically error prone, where you're moving a lot of things around, you end up getting a lot of this. And it takes a while. It's pretty unpleasant, honestly. And you want your tests to save you from this, ideally, because tests are great for regressions. When you make a new feature and you change some small thing, you run your tests again, and it says, oh, hey, something that you thought was true is no longer true. You need to fix that. But the problem is, when you're making such a big change as this, when you're plugging all these things out and plugging them in other places, you just broke all of your tests. So in other words, now I can say, my tests thoroughly cover the design that no longer exists. Kind of a problem. Well, what is the consequence of this? Well, essentially, the consequence is time. It takes a long time. It took us months to get from the first design of this to the final version that we were actually able to ship, because iteration was so expensive and because we wanted to iterate. We did have a choice. We could have, oops, go back. When iteration is expensive, we pay the price in either usability or ship date. So either we could have said, OK, this is not effective, but we don't care, ship it. Or we could have said, OK, we care about it being effective. It's a problem that this first design isn't effective, so we're going to take the time to iterate on it. Iteration's expensive, then you take that route, your ship date gets delayed. It takes months to get it out instead of weeks. Those are months that those teachers could have been using the new interface. So if we could just get cheap iteration, if we could be able to make these changes more cheaply without having to stumble over all these rough edges and undefines or not functions and things like that, angry, loosey, lawless, we could just ship good stuff sooner. It would be better, it would be improved, it would be efficacious, effective, and we could still get it out on time. And the thing is, I knew that there was a way to do this because I'd had this experience with Dreamwriter. So I was here last year talking about Dreamwriter, back when it was React and Flux and CoffeeScript, And at the time, I was talking about it because it totally works offline, but this is just a side project of mine. It's open source. Basically, at some point, I decided that I was going to do a major rewrite. And I was going to rewrite in a functional language, in part for learning, but in part for other reasons. And the language I ended up deciding on was Elm. Some of the things that stood out to me that made me choose Elm for this big rewrite, one was this. It was this benchmark comparing the way Elm fares compared to other JavaScript frameworks at this to-do MVC application. So Elm compiles to JavaScript. It works a lot like React in that it has this idea of a virtual DOM, where instead of saying, I want to change this part of the DOM, I want to change that part of the DOM in this sort of jQuery-like sense, instead you say, here's what I want the page to look like. And then after the user does some input and something changes, you say, now I want it to look like this. And the engine seamlessly for you compares those two versions, does a very efficient diff, and says, OK, here's the minimal set of DOM updates required to make that happen. So what React does, it's what Elm does. So I knew that that was a nice thing, organizationally speaking. React and Flux, big fan. I knew that I could keep that nice organization of wires with Elm, but I would get these other benefits, and one of the benefits would be speed. This would actually be faster, despite the fact that it was compiling to JavaScript, than stuff written in raw JavaScript for React. Nice benefit. Another one was this, the time-traveling debugger. To be honest, I actually ended up not using it that much, but it's very cool, and it has a lot of potential. I think I'm really excited about the stuff that it's going to be when it gets the next couple of versions of it. But if you want to check this out, elm-lang.org, you can check it out. You can rewind time, replay things. Very cool stuff. Semantic versioning is guaranteed for every single package. This might be a big deal to you if you've, for example, hypothetically seen a minor version of _.js get released that breaks everything, hypothetically. So the way it works in Elm is there's actually semantic versioning enforced automatically by the package manager. So what that means is if I make a breaking API change, I change the way something, one of my public interfaces, and I try to push that to the package repo, it will actually give an error and say, I reject your change. I will not accept it unless you bump the major version number. So you actually can really rely on Semver for Elm packages, right? It's awesome. So there were these cool things that were drawing me to Elm for a Dreamwriter. But really, having now used Elm for a bunch, it's not those big flashy things that make it awesome. It's actually, when I think of why I like using Elm and why it's such a nice user experience, it's just the little details, the little polish, the little pieces of user experience that make you feel great on a daily basis. So let me give you an example. So here's some Elm code. We've got a list of numbers, and say numbers equals, and then 1, 2, and 3. I'm going to say first equals, and we're going to call list.head on numbers. So list.head just gives you the first element back out of a list. So in JavaScript, you would say numbers bracket 0, same thing in Ruby. In Elm, you have a function called list.head. I'm going to say double first equals, I'm going to take that first and multiply it by 2. So if first is equal to 1, in other words, the first number in the list, and I multiply it by 2, I will get back 2. Pretty straightforward. OK, so that's easy enough to follow. But there's an edge case here, right? What happens if numbers is empty? Now what happens? So I call list.head, it says give me back the first element, but there is no first element. There aren't any elements. What happens here? So different languages handle this in different ways. Let's start with our good friend JavaScript. In JavaScript, if you were to port this code to JavaScript and run it, you would get double first equals not a number. So it would take the list.head, it would get back undefined, it would multiply undefined by 2 and say that makes sense. Here's not a number. And if you've ever dealt with a not a number related bug, or if you haven't, I suppose, here's what it feels like. You have your interface, and somewhere you've got these nice series of numbers, and one of them just says NaN, and you're like, uh-oh. And then you kind of basically bust out the Tylenol, and then after another hour or so, trace back, OK, this is not a number because this thing had not a number. Why did this thing? Oh, because this thing had not. OK, why was it? Oh, undefined. Right, OK. It's pretty painful. Ruby does a better job of this. So Ruby, list.head of numbers will give back nil. And then if you try to multiply nil by 2, it errors out early. It says no method error, undefined method, asterisk for nil. That's much better. I would much rather have that than have the error silently propagate through my program, meaning that I have to trace back and figure out where it happened. Earlier is definitely better when it comes to errors, when things are going to break. Much prefer this way. Here's what Elm does. So look at this code. I'm going to tell you that this is not a valid Elm program. This actually won't compile. If you run this through the compiler, it will give you an error. This error will never make it to your users. And not just if you have numbers being the empty list, but if you have numbers being any list. Specifically, what it will tell you is you have a type mismatch. So list.head in Elm doesn't return a number, it returns a maybe number, which is sort of an opt-in version of null or nil or undefined. And essentially what maybe says is, look, I'm aware that there's the possibility that nothing's going to come back here. And you should be aware of it too. So what it gives you back is this maybe container that says either I've got nothing inside me, or, in this case, I've got a number. And the compiler's aware of that. So it says ahead of time, look, something is messed up here. The left argument of asterisk is causing a type mismatch. It's got the line number on the left, line 10. It actually squiggly underlines, as if it were Microsoft Word, the actual variable that's got the problem in question. It says, hey, as I infer the type of values flowing through your program, I see a conflict between these two types. You're acting like this is a number, but it's actually a maybe number. You got to handle that edge case. It won't let you forget. Pretty cool. So this is how you handle it. There's a maybe library that has all sorts of convenience functions for dealing with them quickly. The most obvious of which would be with default. So I take list.head numbers, and I pass that to maybe.withDefault 0, which means that if the list is empty, I'm going to get back 0. And if it's got stuff in it, I'm going to get back the first number. This will actually compile. OK, but what if I made a different kind of mistake? So that's not the only type of mistake you can get. What if I had a typo? What if instead of maybe.withDefault, I wrote out maybe.withDefault? That's, again, the type of thing that's going to make Xena Warrior Princess angry in JavaScript land. What about in Elm land? What does that look like? Again, the compiler catches it. Naming error. Cannot find variable maybe.withDefault. This is, again, squiggly red underline, line number. It says, hey, maybe does not expose with default. Maybe you meant one of the following, maybe.withDefault. So it actually tells you the thing that you messed up. It tells you the right version. Right? Come on. Yeah. This is how it ought to be. When you mess something up, you ought to have a helpful compiler that tells you what you messed up, not just undefined is not a function, deal with it. This is so much better. If you would like to take the stuff we just learned and actually build a complete UI, that's too long for this talk, but I have a blog post called Building a Live Validated Sign-Up Form in Elm. There will be a link to it on the slides afterwards. And if you like, it starts from just assuming that you know JavaScript and nothing else, and just takes you all the way through building this live validated, Ajax, the whole nine, in Elm. So no prior Elm or functional programming experience required. Start to finish, just JavaScript. OK, so here's a fact about Elm. Everything in Elm is one of two things, immutable data and stateless functions. So immutable data means you can't change it. Once it's instantiated, that's it. No changing it, no changing anything inside it, no changes ever. If you want a new version, you're going to copy it. Fortunately, Elm uses persistent data structures under the hood, which means that copying these things is actually very fast. It doesn't actually copy the whole thing. It only copies whatever is necessary and has all sorts of nice optimizations around that, which is exactly how it can do really well on that to-do MVC benchmark, despite the fact that everything is immutable data. Stateless functions, if you're not familiar with them, also known as pure functions, referential transparency, stuff like that. I like the term stateless. It's nice and descriptive. Essentially, the way they work is you have a function. It takes values in, and then it returns a value, and that's it. It has no side effects. It doesn't look at the outside world, doesn't read from a database, doesn't do Ajax, doesn't do any of that stuff. It just looks at its inputs and returns a value. If you give it the same inputs, it will every single time return the same value, and that's it, with no side effects. So at this point, you may be wondering, I just said a minute ago that I've got this blog post where allegedly we're doing Ajax. I also then said everything in Elm is stateless functions, which are not allowed to do Ajax in the middle. What's up with that? So essentially, the way that Elm does effects is instead of doing them as side effects, where you can have them in the middle of any program, it does what are called managed effects, which is you represent your effects as data. So instead of saying, I'm going to imperatively run this line of code, and it's going to do this thing as soon as I hit that line of code, what you're doing instead is you're building up a description of what you want done, which you then ultimately hand off to the runtime, and the runtime performs that. So you'd say, essentially, you have these things called tasks. So a task is just a data representation of stuff you want done. It's a list of instructions. You can think about writing them down on a scroll. So instead of the action you're doing being going to the store and buying a list of things, what you do instead is you write down, go to the store, and then buy this thing, buy that thing, buy that thing on a scroll, and you hand it to a lackey who does it for you because doing things yourself is for suckers. So essentially, tasks let you accomplish the same sorts of things, just in a different way. And this is sort of a recurring theme in Elm. It's that you're doing the same kinds of things that you were before, you're just doing them in a slightly different way. And we'll see what that gets us a little bit later. So tasks are composable like promises. They have a notion of success or failure. You can chain tasks into other tasks to build up an even bigger description of stuff you want done that can branch off and chain conditionally and stuff like that. But like callbacks, they are harmless to instantiate. You can instantiate as many tasks as you want, and doing that instantiation is just like writing stuff down. It doesn't actually cause anything to be done. It's only once you ultimately hand it off that something else actually runs them. So here's an example. http.getString. HTTP is Elm's Ajax library. It's really nice. GetString is the simplest, most bare bones one you can do. You give it a URL, and it's going to give you back a task, which will go hit that URL, take whatever it gets back, and give it to you as a string. There are other ways to deal with JSON and stuff like that that are nicer than this, but this one's the simplest. The point is, if I run http.getString, what I'm going to do is get back a task. And I can then hand that task off to someone else, but calling this code, running this line of code, does not make any network requests. I can run this code 100 times, 0 network requests. It's only once I take the task that it returned and hand it off that it actually gets run. What this gets you is these great guarantees. So think about this for a second. Suppose you have a JavaScript function, and it's calling 5 other functions. And each of those functions is calling 5 other functions. And there's just this whole big graph of things going on, functions calling other functions. And at the end of the day, you have this bug where by the end of somewhere in your code, local storage got into a weird state. Something modified local storage. You're not quite sure what. And you're looking at this function that calls other functions and functions and functions, and you're like, who did that? I don't know. How do you find out? I guess you start grepping for local storage. Sure hope that string doesn't appear a lot of times in your code base. Maybe it was in this function, maybe it was somewhere else. In Elm, you can just look at what that one function returns. Doesn't matter how many other things it called. Did this function alter local storage? No, because it returns a string. If it returned a task, it might have been able to alter local storage, because altering local storage is an effect. But this function calls all these helpers, but at the end of the day, I can see right there very clearly, it returns a string. So rather than spending debugging time digging through all those functions or grepping for a very common string throughout my code base, I can just say no and move on. Imagine what this does to your debugging experience. Did something mutate this value? We've got a bunch of functions calling other functions. In JavaScript, you could have a global. You could have all sorts of ways that this function could interact with this other function, even though neither of them is calling one another. In Elm, nope. Values can never be mutated. That's just a guarantee. You just know that. If you're trying to hunt down a culprit, you can say, yeah, no, it couldn't be that, because that doesn't exist in this whole language. Did I miss any cases in this refactor? I renamed this thing. I've got a big code base. In a lot of cases, you find out maybe days later, maybe weeks later. Hopefully, you have an integration test that finds it, but maybe not. And there's an error that comes up. But in Elm, that error happens at compile time. Even though it's some file you haven't touched in 6 months, the Elm compiler still remembers it, still checks it, and says, hey, forgot about that one. Cool. So whenever you do a refactor, you can be really confident that you didn't miss any cases, because if you did, the compiler would have told you about it. All of this gets you this. Once it compiles, it typically works on the first try, with no regressions or runtime exceptions. This is just what life's like in Elm. This is normal. People who have done this will back me up on this. And let me give you an example of this. So this is Dreamwriter, again, open source on GitHub. This is a pull request I made. I made a couple of changes here. There are a few things that changed. I guess you could say the diff there's a diff, like I guess 1 or 2 alterations. There were some deletions, maybe some additions. Okay, so some stuff changed, right? When this compiled, it just worked on the first try with no regressions and no runtime exceptions. And if you think that's crazy, what's also crazy is that I've had this experience so much, I was like, well, yeah, of course. Like, that's just normal. Okay, I don't care how big the diff is. It's just, yeah, it's not going to break. That's just what my life's like now. I have to be careful not to get used to this, because maybe I won't work at NoRedInk forever and I can't use awesome tools like this. But man, am I enjoying it while I'm here. Okay. So let's come back to active voice and passive voice. So I was retrospecting on this with my teammates and thinking about how long it took us to ship this thing using React, Flux, and CoffeeScript. And I couldn't help but think, I've had this experience with Dreamwriter. If I'd written this in Elm and said from the get-go, it would have shipped sooner, even counting all the setup costs, even counting all the stuff that comes with using a new language, all of the sharp edges that you find out because you're kind of on the frontier and there's just not been that many people exploring it. Even counting all that, counting the learning curve, it still would have shipped faster, and then I would have ended up with much more maintainable code. So why didn't I? I mean, I knew about it. I knew that was an option, but I didn't do it. Why not? Well, because I was scared. I mean, it's a scary thing, you know? You jump and you're like, this is going to be awesome. But then you're midair and you're like, am I actually going to land this? I don't know. And you really can't know until you do it. So I thought back to the experience that I had with React. Like I said, we adopted React right when it came out. I mean, looked at that and said, this thing is great, let's try it out. We did. There was a lot of risk at the time. React's pretty mainstream now, but at the time, it was a risky thing to do. There was a lot of setup time. Again, because it was very new, we were apparently one of the first people using React with Internet Explorer 8, which we don't support anymore, thankfully, but back then we did. And we actually ran into some documentation problems where it was describing how to get things working in IE8 and it didn't work. So then I got to become a React contributor, technically, by fixing that. But it's one of those things that just comes with using something very new. And of course, there was learning curve. Nobody on our team knew React. We had to learn it, and then we had to teach each other what we'd learned. Was it worth it? Oh, yeah, it was so worth it. It was amazing. I mean, comparing our experience with React to the stuff we were doing before, it's just so much better. Everything is cleaner. The problems that we were having went away. So I'm reminded of this amazing quote by Tina Fey. You can't be that kid standing at the top of the water slide overthinking it. You have to go down the chute. So we did. We went down the chute. We said, look, let's not make this mistake again. We know Elm will solve these problems we've been having. Let's do it. So here's what we did. We chose a small, unscary project to try out Elm. Specifically what we did is we took one of our Flux stores, just one, and we pulled out all the logic that was in CoffeeScript and replaced it with Elm. And essentially the way we did that is using Elm's port system. So if you haven't heard of this, this is how Elm does interoperation with JavaScript. So essentially you have all these guarantees in Elm land. You don't want to sacrifice those. And sharing code with JavaScript is a pretty good way to start introducing those JavaScript type bugs back into your application. We don't want that. So the way Elm deals with that is by talking to JavaScript basically like it talks to a server. You just pass data back and forth. So you're using these ports, you can say, I want to send some data out to JavaScript, or I'm going to get some data back in from JavaScript. It's a pub-sub system. So essentially, there's no code sharing. It's just got the same kind of characteristics as you have when you're talking to the server. You don't really care what the other language is. In this case, it's JavaScript. OK, whatever. Obviously, this is a lot faster than talking to the server, because instead of doing the network connection, it's just more of an abstraction. But the basic idea is that you get to preserve all of your guarantees while talking to JavaScript. So we use this in all sorts of ways. We use this for date picker libraries that we don't want to re-implement, full text search indexing, just any kind of JavaScript library that we don't want to rewrite in Elm, we will just use a port to talk to it. And that's exactly what we did in this case, except it was a port talking to our old code. So we were able to do this change and replace all of the logic in this one Flux store with Elm logic without changing any other JavaScript files. Basically just each of those methods, instead of having a bunch of logic in them in CoffeeScript, we ripped all that out and it just had one line that said send out to an Elm port, and that was it. So that worked, and then we got a good sense for what it was like to get Elm integrated into our build process. There were some sharp edges there too. We had some stuff where we had to figure out how to do things on ourselves because nobody else had done an Elm integration with Rails. And now we've benefited from you guys who don't have to run into those because we did. But it was worth it. So if you're wondering how to do that, also have a blog post on that, introducing Elm to a JS web app. And it's basically doing exactly the same thing we did, except with the Flux to do MVC application. So it's just taking that and then ripping out the guts and replacing it with talking to Elm. So if you're wondering how to do that, check out our company blog. It's got a post on that too. OK. So again, we're faced with the same thing as we were with React. We've got risk, we've got setup time, we've got learning curve. Was it worth it? So worth it. Whoa. I mean, this was like, React was a big upgrade. This is just mind-blowingly good. I mean, here are just a short list of things we've seen. So fewer bugs, way, way fewer bugs. Our Elm code is just way, way miles ahead as far as bugginess than our old stuff. I mean, the compiler can't catch absolutely everything, but man, does it catch a lot. Improved team spirit. People are really excited about using it. People are happy using it. It's been an awesome experience. People just start smiling when we start talking about it. We've seen an increase in job applicants. People are excited about working for us just because we're using this cutting-edge, awesome technology. By the way, we're hiring. And a surprisingly low learning curve. I mean, this is about as hardcore as functional programming gets on theoretical levels, right? Everything's immutable. Only stateless functions anywhere. You would think that because that's so different on paper, that it would take a long time to get up to speed. I don't know how else I can dispel that besides telling the story of one of our coworkers. Basically, she was not a programmer. She went through a boot camp where she learned JavaScript. Her second day on the job, this being her first programming job, she was writing Elm code for production unsupervised. It can happen. I mean, she's really awesome, so I don't know if I should make the claim that everyone can do that, but It's totally doable. I mean, you can get up to speed doing that. And the way we did that was just through a bunch of pair programming. We have a big culture of pair programming. We do it about 50% of our time is pairing. We even do remote pairing with our remote people. And that was all it took, was just a week or so of that, and she was up to speed. She's off and running. So, in summary, we have a clean UI architecture, the same kind of stuff as React and Flux, a delightfully helpful compiler that I really hope I never have to live without again, semantic versioning guaranteed for every single package, and change is cheap. It's so cheap that we now just refactor pretty much at the drop of a hat. We were just talking the other day, and I estimated off the cuff that we probably refactor our Elm code about 3 times as much as our CoffeeScript code, just because it's so easy. I mean, we'll come through and we'll make some change, and we'll say, oh, you know what, this could be better. Why don't I just change that? And you'll make the change, and if it compiles, you're just pretty confident that it's going to work. And basically, pretty much always does. In short, stuff is reliable. It's really nice. So we started off asking, why can't JavaScript be more like Ruby? This thought that I've had all the time. And I was so jealous of what people got to use on the back end, because what I had was just so much clunkier and less nice to use. But now I've come full circle, and with Elm, now I'm asking the question, why can't Ruby be more like Elm? Thanks very much.